morning students, I welcome you all in this lecture. Today I am going to discuss the double integral and we will learn how to evaluate the double integral. So consider double integration. So consider a function fxy which is your continuous function defined in a closed and bounded region R. So let us define this function in a closed and bounded region R. Say this is your closed and bounded region R. Now I will divide this region in your infinite number of rectangles parallel to the coordinate axis. So if you divide this rectangle in rectangles by the lines parallel to the x-axis, then we will have such type of rectangles. Now we have rectangles. Suppose that this is your rth rectangle and the point at this rectangle is your xr comma yr, and suppose that this is your point in this rectangle and the area of this rectangle is delta AR, which will be your delta XR into delta YR. Now this is your rth rectangle. Now if you increase the number of rectangles, then clearly your area of the rectangle will get decreased. So if you increase, so if n is the number of rectangle, so if your n is the number of rectangles, then as n tends to infinity, your area of the rectangle will tend towards the 0. So if your n is the number of rectangle, and if you increase the size of the rectangles, if you increase the number of rectangles, then this area will definitely get decreased. So consider the sum, say s equal to r equal to 1 to n, your fxr yr delta AR, and your delta AR is delta XYR, delta XR into delta YR. Now if you take the limit of this sum, then this will give you the double integration. So if n tends to infinity, then your delta AR will tend towards the 0, then this limit is said to be, then this limit n tends to infinity of r equal to 1 to n fxr yr delta xr delta yr is said to be your double integration of fxi over the region R. So this is known as your double integration of the function fxy over the region R. Now we will learn how to evaluate this double integration. So evaluation of the double integration. evaluation of the double integral. Now consider the double integral, say fxy dx dy. Now this is your case 1. In this case, let us assume that the limits of x are constant and the limit of y varies. Now if the limit of x are constant, say x equal to a to x equal to b, and say y varies from some function of x to another function of x, then we will evaluate this double integral first with respect to y then, as this is your limit of y, as this is our limit of y, so we will first integrate this function with respect to y, and then we will integrate with respect to x. If you want to write this dx here, then you can write it. So we first integrate this integral with respect to y, because we have the limit of y in terms of x. So first we will integrate with respect to y and then with respect to x. So in this case, we first integrate with respect to x, with respect to y, then with respect to x. So this is your case first. Then consider the case 2, where the limit of y are constant and the limit of x are in terms of your y. Now in this case, we will first integrate, with respect to x Now here we will first integrate with respect to x and then with respect to y. Because our limit of x are in terms of y, so we will try to remove our x first, and then finally we will have y, and we will integrate y with respect to, we will integrate the function of y with respect to y. So here in this case we will integrate first with respect to y, with respect to x, and then with respect to y. So this is your case 2. Now case 3, when your both limits are constant. So our case 3 is consider the case when your limit of x and y are both constant. Here you can see that our limit of x and y both are constant. So in this case we can integrate first with respect to x, then with respect to y, or vice versa, first with respect to y and then with respect to x. So if your limit are constant, then you can integrate with respect to anyone. So in this case we can write it as x equal to a to b, y equal to c to d, fxy dy. You can write it like this, and even you can like it, this you can integrate first with respect to your x, then with respect to y. So in this case we can either integrate first with respect to x, then with respect to y, or first with respect to y, then with respect to x. So here we have choice that you can either integrate first with respect to x, or then with respect to y, or first with respect to y, then with respect to x. Now Let us solve few questions based on this double integration. So the question number 1 is to evaluate the double integral. Question: evaluate the double integral over the region, over the quadrant for which we have x plus y less than equal to 1. So in this case, just evaluate this double integral for which your x plus y is less than equal to 1. So your solution here, in our case, our x plus y is less than equal to 1. So say this is your x-axis, this is your y-axis, say this is your y equal to 0, this is your x equal to 0, and here we have x plus y less than equal to 1. Now, in this case, we do not have given any limits, so let us guess the limits of x and y. Now here we have two choices. You can either take the limit of x constant and vary your y in terms of x, or take a limit of y constant and then vary the limit of x in terms of y. So for that, we can take either our vertical strip or horizontal strip. So by taking this vertical strip, we can vary our y in terms of x. So let us take the vertical strip. Here you can see that this is your 1, 0, this is your 0, 1. Now the value of y, now just take the lower and upper end of this strip. So here, if you take at the lower point of this strip, if you vary this strip from this point O to A, then you can see that your limit of y will be always from 0 to 1 minus x. If you move this strip from this point O to A, then your limit of y will never change. It will be always from 0 to 1 minus x, because this lower end of the strip will be in this x-axis and the upper end will be in this line, x plus y equal to 1. So here for this strip, our y will start from 0 to 1 minus x. Now what about the limits of x? Just take this strip at the lowest point of this region. Say this is your starting point of this region. So at this point the value of x is 0. And then take, so I have moved this strip to this point. Now if you again move this strip to its largest point, then you can see that your strip will come here, and at this point our x is 1. So our x will vary from 0 to 1, whereas our y will vary from 0 to 1 minus x. So this is when you take the vertical strip. Now if you take the horizontal strip, say like this, now in that case your x will vary from 0 to 1 minus y, and then take this strip at the lowest point, that means at the origin, then here our y will be 0, and then take the strip at the largest point, then here our y will be 1. So in that case your x will vary from 0 to 1 minus y, and your y will vary from 0 to 1. So in our case I am taking the vertical strip. So thus the double integration of xy dx dy is equal to, now the limit of y are from 0 to 1 minus x, and the limit of x will be from 0 to 1. Then we have xy and dx dy. So first we will integrate, because our limit of y are in terms of x. So first we will integrate with respect to x, with respect to y. So here we will write this one as like this, y equal to 0 to 1 minus x, then we will have y into dy, and the integration of y will be y square by 2. So this will be your For the upper limit we will have 1 minus x whole square upon 2, and your lower limit is 0, because if you put y equal to 0 we will get 0. So this is equal to 1 by 2, 0 to 1, 1 minus x square dx. Now the integration of 1 minus x square will be, this is equal to, now the integration of power 2 will be power 3 upon 3, so we have 1 minus 1 by 6, because again the integration of 1 minus x will give you minus sign, so integration of x square will be x cube upon 3, so we have 1 minus x cube upon 3 to just 6 is here, and the limits will be from 0 to 1. Okay, now if you put, I think I forgot to write this x, so we have x again, 1x is here, so we have 1 more x. So before doing integration, let us simplify this one. So this is equal to 1 by 2, 0 to 1. Now integration of 1 minus x, square of 1 minus x square will be, so this will be 1, so we have x plus b square, so we will have x cube, then we will have minus 2x, so this is your minus 2x square into dx. Now the integration of x will be x square by 2, then we will have x power 4 upon 4, then here we will have x cube upon 3, and this is equal to, now this will be your, say 12, 2 6 are 12, 4 3 are 12, and 3 4 is 12, so we have 8. So this is your 1, and the answer is 1 by 24. So the value of this double integration for this region is 1 by 24. Then our next question, is to evaluate the double integration x plus y, x square plus y square dx dy over the region bounded by the planes, bounded by the lines y equal to 4x, x plus y equal to 3, y equal to 0, and y equal to 2. So evaluate this double integration where your region is bounded by the 4 lines, and the lines are y equal to 4x, x plus y equal to 3, y equal to 0, and y equal to 2. So our solution, now let us draw the region. So say this is your origin, your y equal to 0 will be this line, your y equal to 2 is this line, say this is your 0, 2, and this is your 0, 0. So we have drawn 2 lines. Then your x plus y equal to 3, so this is your y equal to minus x plus 3, so that means, and the intersection of x plus y equal to 3 and y equal to 2 will be, so the intersection of these two lines, if you put y equal to 2 here, then your x will be 1, so your x will be 1, so you can, and again if you put x equal to 0, then your y is 3, so the line will be like this. Here this is your x plus y equal to 3. Now if you put y equal to 2, then your x is 1, so this is your 1, 2, and at this point your x is 0, so we have y equal to 3, so this will be your 0, 3. At this point we have x equal to 0, so our y will be 3, and at this point this is your intersection of x plus y equal to 3 and y equal to 2, so here we have x equal to 1, so we have this point, and this one. Now the last line, which is your y equal to 4x, y equal to 4x will be basically a line passing through origin. Now let us find out the intersection of y equal to 4x and y equal to 2. Now you can draw y equal to 4x from here. Now let us find out the intersection point. So if you put y equal to 2 here, then you can see that your x will be, if you put y equal to 2, then this will be 2 equal to 4x, so your x will be half. That means this line will be here. Say this is your x equal to half. So this is your y equal to 4x. That means your required region is this area. So this is your required region. Now we have to evaluate this double integration for this region. So for that, let us draw a horizontal strip. So we have this horizontal strip. Now for this horizontal strip, our x will vary from y by 4 to 3 minus y. This will be the limit of x, and then your y will be from 0 to the highest point, which is your, and here we have y equal to 0, so we have x as 3, 0. So your y will vary from 0 to 2, and your x will vary from y by 4 to 3 minus, your y will vary from, your x will vary from y by 4 to 3 minus y. So the double integration is given by, hence this double integral x square plus y square dx dy is equal to, your x is from, your y is from, your y is from 0 to 2, and your x is from 0 to, sorry, your x is from y by 4 to 3 minus, your x will be your 3 minus y, and we have x square plus y square dx dy. Now here you can see that this is your limit of x, so we will first integrate with respect to x, then with respect to y. So we can write it as y equal to 0 to 2, then write dy here. So this will be y by 4 to 3 minus y, and we will have x square plus y square into dx. Now the integration of the bracket will be, so as we have to integrate with respect to x, so this y will get will be constant. So the integration of x square will be x cube upon 3. Your y square is constant, so we have y square into x, and then the limits from y by 4 to 3 minus y, and this is equal to y equal to 0 to 2. Just put the limits here, then we will have 3 minus y whole cube upon 3, then put the lower limit, which is your y by 4, so we have y cube upon 4 cube. So 4 cube will be 64 into 3, 192, and here we will have y square into 3 minus y, then our lower limit will be, just put the value of x as y by 4, so this will be your y cube upon 4. Now we will integrate this term with respect to y. Now let us integrate this term with respect to y. Now if you integrate this term with respect to y, then your answer will be, okay, let us simplify this one. So on integration we have this one equal to, so the integration of this will be 3 minus y power 3 up 4 upon 4 minus 4, so this will be a minus 12. Now the integration of y cube will be y power 4 upon 4, so we have 4 into 192. Then we will have here 3y square, so 3y square means y cube upon 3. Then we will have y cube, integration of minus y cube will be y cube upon 3. So this is your 3y square, so y cube upon 3, and so this 3 will get cancelled, so this will be simply y cube, and we will have y cube, integration of y cube will be y 4 upon 4. Then we will have integration of y power cube will be y 4 upon 4. So this will be 16, and then the limits from 0 to 2. Okay, this is your 3 minus y power 4 upon 4, so we have 12. Y power 4 upon this one, then we will have 3y square, so this is your y cube. Then we have minus y cube, that means your y4 upon 4, then your y4 upon 16. So just put the values of y as 2. So if you put y equal to 2, then this will be your 3 power 4 upon minus 12, and for the lower limit we will have plus 3 by 4 upon 12. For the upper limit, just put the y value of y as 2, then this will be 1. So we have just 1. So this is your minus 1 upon 12. Now if you put y equal to 0, then this will be your 3 power 4, and your minus will get plus. Now if you put y equal to 2, then this will be your 2 power 4 upon 4 into 192. Here we will have 2 to the 4 to the 8, 16 upon 4, then again 16 upon 16. So now this is your minus 1 upon 12. Now this is your 81 upon 12. Now this 16 will give you, this will be your 12. So this is your minus 1.48, and then we have 8 minus 4 minus 1. Now this will be your 80.12. Then we have 8 minus 4, so this will be 4 minus 1, so we have plus 3. Now if you take the LCM as 48, then this is equal to 4 times, so this will be your 320. Then we have minus 1, then this is your 48 into 3. So 48 into 3 will be, so this will be your 4, then we have 144. Okay, now this is equal to, now this will be 143 plus 320. So this is equal to 3, 4 plus 2, 6, 4, 63.48. And this is your answer of this problem. Then the next problem is, our next problem is to evaluate the value of the double integral r xy dx dy, where your r is the domain bounded by x-axis, ordinate x equal to a, and the curve x square equal to 4ay. So evaluate this double integral where your r is the domain bounded by x-axis, the ordinate x equal to 2a, and the curve x square equal to 4ay. So your solution, your curve x square equal to 4ay will be this one. Now your ordinate x equal to 2a will be somewhere here. This is your x equal to 2a, and your x-axis is this one. So your required region will be, your region is between the ordinate x equal to a, your x-axis, and the curve. So that means this is your region. And so the limits will be your x will vary from 2 under root ay to x equal to 2a, and your y, let us find out the intersection. So this will be your x equal to 2a. Put the value of x equal to 2a here, so this will be your 4a square, so we have a here, and this is your origin, and this is your, say, a. So the value of the double integral is equal to, now here you can see that your x will vary from 2 root ay to 2a, and your, so we will first integrate with respect to x. So this is your y equal to 0 to a dy, and then 2 root of ay to 2a, then integration of this bracket with respect to x. as we are going to integrate with respect to x, so our y will be constant. So this is equal to y equal to 0 to a dy, and then the integration of this x will be x square by 2. So we have y square by 2. So we have x y upon 2 into x square, and then the limits will be from 2 root a y to 2a. So this is equal to y equal to 0 to a y by 2 into the limit. For the upper limit, put x equal to a, so this will be 4a square, and for the lower limit we will have 4 into a into y, then the integration with respect to y. So this is equal to this is equal to 0 to a, just put this y inside the bracket and divide it by 2. So in the bracket we will have 2a square y, then 2a y square, and then the integration with respect to y. So the integration of y will be y square by 2, so we have a square y square. Here we will have y cube upon 3, and then the limits from 0 to a. So this is your a cube, a power 4, minus, here we will have a power 3 into a, so this will be your 2 upon 3 a power 4, and this is equal to a power 4 upon 3. So this is your answer. Then our next question is, to find the area between to find area between the circle x square plus y square equal to a square and the line x plus y equal to a. So let us find out the area between these two curves. Now, so the important application of this double integral is to calculate the area of a surface. So our solution, let us draw these two curves. One is the circle and the another one is the straight line. So your circle is this one. So this is your center origin, and we have radius a, so we have a comma 0 here. Again this is your 0 comma a, and this is your origin. Now then we have a straight line x plus y equal to a, and the intercept of this straight line will be, if you put x equal to 0, then we will get y equal to a, and if you put y equal to 0, then we will get a, x equal to a. So that means our intercepts are a and a, so that means this is your straight line. Here you can see that this is your intercept with the x-axis, and then this is your intercept with the y-axis. So the required region or required area is this one. So the area between these two curves is this shaded region, and for that let us take the horizontal strip. So the area of the shaded region is equal to the double integral, say this is your a, so the area over the shaded region, so this will be your just dx dy. This will be your double integral dx dy, and this will represent your area of the shaded region. And now let us find out the limits. Your limit of x will be from, here you can see that in this line your x will be from a minus y, and the other point of the strip is on the circle, and here we have the value of x as under root a square minus y square. Please note that here I am not taking the negative sign because we are above on the right hand side of the x-axis. So, and the limit of y will be from 0 to a dx dy. Now this is equal to y equal to 0 to a. So here we have the limit of x in terms of y, so we will first integrate with respect to x. So the integration of dx will be your x. So for the upper limit we have under a square minus y square, and for the lower limit we have a minus y, so we will have minus a plus y, and then the integration with respect to y. Now this is equal to, so this is equal to now the integration of the first term will be, now let's just use the formula, and this is equal to y upon 2 under root a square minus y square, this is your y, under root a square minus y square plus a square by 2 sine inverse y upon a. So this is your formula for under root a square minus y square. Then the integration of a with respect to y will be your ay, then we have y square by 2, and then finally put the limit of y from 0 to a. Now here the first term will be 0 for the both upper and low limit. Here our upper limit will get exist for y equal to a, and this is your sine inverse 1, and sine inverse 1 is pi by 2. So we have pi by 4 into a square. Then this will be your a square. Put y equal to a, so this will be again a square by 2. So your answer is equal to pi a square upon 4. Now this will be your minus a square by 2. Now if you take a square by 4 common, then in the bracket we will have pi minus 2. So this is your answer. So a square by 4 into pi minus 2. Now our next question is to find the area between the two parabolas Our next question, to find area between the parabola y square equal to 4x and x square equal to 4ay. So solution, so the parabola x square equal to 4ay will be this one, upward parabola, and then we have this parabola. So the area between these two parabolas is this shaded region. So this is the area between these two parabola. Now let us find out the intersection point. So if you put the value of y here, then you can see that this will be your x power 4 upon 4a square. One x will get cancelled, so we will have x cube equal to 4a cube. So your x will be 4a. So the intersection point will be 0, 0 and 4a, and if your x is 4a, then again y is 4a. So our intersection points are 4a, 4a. Now if you take the horizontal strip, then your area will be, area is equal to this shaded region, and for this shaded region your x will vary from, here our x is equal to y square upon 4a, and in this parabola your x will be 2 root ay, and then the value of your y will be from 0 to 4a, and we have dx dy. So let us integrate first with respect to x. So this is equal to integral 0 to 4a. Now this will be your 2 root ay minus y square upon 4a, and then the integration with respect to y. So now the integration of y power half will be y power 3 by 2 upon 3 by 2, and here we will have y cube upon 12a, and then the limits from 0 to 4a. Now this 2 will go in the numerator, so this will be 4 upon 3 square root of a, then the value of y cube will be your 4a whole cube, and here we will have 4a whole cube divided by 12a. Now so this root y will be y power 3 by 2, so we have 3 by 2 here. Okay, now this is your 4 power 3 by 2 means your 2 power 3, so 2 power 3 will be your 8, 4 is 32, so we have 32 upon 3 then this is your a root a, and this a power 3 by 2 can be written as your a root a. So this is your a square. Again, this will be your 64. So this will be your 16 upon 3 a square. So this will be your 32 minus 16 will be your 16 upon 3 a square. So this is the area between these two parabola, and your answer is 16 upon 3 a square. Now our next question is to find the area lying between our next question is to find the area lying between the parabola y equal to 4x minus x square and the line y equal to x. So your solution, now let us draw the parabola. So before drawing this parabola, let us write it in standard form. So this is your x square minus 4x equal to minus y. So we can write it as x minus 2 whole square equal to 4 minus y. So we can write it as y minus 4. Now here you can see that this is your x square equal to minus 4ay, and this is your downward parabola with vertices as 2, 4. So we can draw it like this. So this is your parabola with vertices as 2, 4. Now let us find out the intersection of this straight line and this parabola. So if you put y equal to x here, then you can see that your x equal to 4x minus x square. So we will have x equal to 0, 3. And if you put x equal to 0, then we will have y equal to 0. And if you put x equal to 3, then we will have y equal to 3. So the intersection point are 0, 0 and 3, 3. So your area will be equal to double integral dx dy. And if you take the vertical strip, then here you can see that your y will be from x to 4x minus x square, and your x will vary from 0 to 3. So your x is from 0 to 3, and your y will vary from x to 4x minus x square, and then we have dx dy, and the integration of this bracket with respect to y will give you 4x minus x square minus x. And if you integrate this term with respect to x, then we will have, this will be your 3x. So we have 3x square upon 2 minus x cube upon 3, and then the limits from 0 to 2. Now this, here your x is 0 to 3, not between 0 to 2. So your x is from 0 to 3, so we will have 9. This will be your 3 3 are 9 minus 3 into 3 will be your 27 upon 2. Again your 27 upon 3. So this is your 1 upon 6. So this is equal to 9 upon 2. And this is the area between these two curves.